Hello everyone, greetings. My name is Adriana from Chemical Engineering 2020, Faculty of Engineering, Universitas Indonesia. And in this moment, I would like to present my capstone project for the completions of the Exploration and Production of Hydrocarbon Class 2022 regarding the Ubadari Field and Purwatta Carbon Capture, Utilization and Storage, or CCUS project in Binsuni Bay, West Papua by BP and Tangguh LNG. And here's several overview of the project locations. So these fields are located in Binsuni Bay, West Papua. And for the Purwatta field, it was discovered in 1997 by ARCO and is currently operated by BP. And this field has been producing gas since 2009, where the gas produced from this field will be processed into liquefied natural gas by Tangguh LNG in their processing plants in Papua. And this Purwatta field has the estimated ultimate recovery of 1,833 million barrels of oil equivalent. And as for the Ubadari field, it was also discovered in 1997 by ARCO and is currently operated by BP. And it's supplying gas after the Tangguh LNG Train 3 project is completed in 2020. And it has the UR of 500 MMBOE. And the case that is given to me is that about this new recently approved POD of the CCUS project in Ubadari and Purwatta field in Papua, where this new development is estimated to enable a potential additional recovery of 1.3 trillion cubic feet of gas from both the Ubadari and Purwatta CCUS project. And here is some field information about the Purwatta field. First, the reservoir descriptions. So the locations where the Purwatta field is located has the water depth ranging from 50 to 60 meters, and the well depth is 4.6 kilometers. And this reservoir produces 1 billion cubic feet of natural gas per day, where the gas streams contains 15% of carbon dioxide and 1% of hydrogen sulfides. And for the offshore facilities, these fields have two platforms. First one is Purwatta A and Purwatta B, and each platform has 10 production wells. That makes them 20, not including the additional wells to support production, and several other supporting facilities for each wells and each decks. And there is no offshore processing facilities because the gas is transported to be processed in the onshore facilities by the Tangguh LNG. And for the pipeline networks to connect from the wells to the processing facilities onshore, the Purwatta A has 22 kilometers of pipelines and Purwatta B has 15 kilometers of pipelines. Unfortunately, I cannot find the same information for the Ubadari field, and I apologize for that. Moving on to the CCUS project. So the background is because the Tangguh Reservoir gas stream in Papua has high percentage of CO2 level ranging from 12.5 to 15%. And during the time span of this project, it is estimated to be at least 1.8 trillion cubic feet of CO2 gas. And imagine that high amount of CO2. And to reduce the emissions through the Tangguh project, the plan is to inject the CO2 back into the ground. So by injecting back 25 million tons of carbon dioxide back into the Purwatta reservoir. And by doing so, this plant can counter carbon emissions and provide incremental gas productions through enhanced gas recovery. Therefore, this project can still serve its purpose to reach the national target of gas productions by 2030, as included in the national strategic project by the Indonesia's government, while at the same time, it could counter the carbon emissions to contribute to Indonesia's government's commitment under the Paris Agreement regarding the reductions of carbon dioxide emissions. And also, another beneficial outcomes from this project is that this CCUS or this carbon capture can free this project from the carbon tax cost because of this recent regulations regarding carbon tax. So based on the UU number 7, year 2021, article 13, where the carbon tax rate implemented in Indonesia should be higher or equal to the carbon price in the carbon market with a minimum range of 30 rupiah per kilogram of CO2 equivalent. It is still way lower than the recommendation from the IMF, which is 75 in rupiah for each kilogram of CO2 equivalent. But remembering the amount of CO2 produced from the Tangguh gas streams in Papua, imagine the high amount of cost that they have to pay because of their emissions of carbon dioxide. But these implementations of the CCUS project in Forwata field can help free the BP and Tangguh from the high carbon tax cost if it's being implemented successfully in the future. And for the CCUS plant, the carbon dioxide recovered from the gas streams can be used for the EGR or enhanced gas recovery, which is a technique to increase the ultimate recovery of natural gas and gas condensate through the injections of carbon dioxide in a gas field. And this project has the estimated capacity to produce 4 metric tons of CO2 per year. And by the EGR, it is estimated that these fields can recover 300 billion cubic feet by 2035 and 520 billion cubic feet by 2045. And the plan for CCUS, or to be utilized for the enhanced gas recovery, is first, they have to study the effect of CO2 injection parameters such as temperature, position, pressure, and rate. And after their simulations, for the CO2 EGR method has to be conducted in a heterogeneous gas reservoir by using isothermal and non-isothermal models. And the last is to analyze the effects of the various CO2 injection parameters, such as the effects of this gas recovery, the effects for the CO2 storage, as well as for other comprehensive benefits from the injection parameters. And here is small illustrations about the CCUS project. First is the carbon has to be separated or recovered from the gas streams, and then it's transported via pipelines to the geological storage underground, and then it's transported again via pipelines to be injected back to the well or to the reservoir, to the Forwata reservoir. And despite the beneficial outcomes from this project, just like any other projects, it has challenges and risks. First of all, this project requires the capture plant, the transport pipelines, as well as the geological storage, which requires investment in capital-intensive long-life assets. And if there is any failure during injections, it can release a large amount of CO2 instead of reducing it as the purpose of this project in the first place. And from the previous small illustrations, we have seen that the geological underground storage is located very close to the reservoir. So if there is any possible leak, the well bores will provide the pathway for the carbon dioxide to escape to the surface. Therefore, it could contaminate the groundwater and the soils. However, there are some strategies or mitigations to mitigate the possible risks and challenges by investing or by having access to high quality CO2 geological storage resources that have 3 characteristics. First is the capacity. So suitable geological storage should have the capacity to accept the intended volume of carbon dioxide, and then the injectivity to take in the CO2 at the rate that is being supplied to the storage, and then confinement to prevent the migrations and leakage of the buoyant and mobile CO2 from the storage space to other places in the subsurface and or to the surface. And these circumstances can reduce the cost associated with capture, storage, site appraisals, CO2 transport, and CO2 storage operations. And so to conclude my presentations for today, so carbon capture, utilization, and storage is the future of Indonesia's energy sector, because this project can reduce the carbon dioxide emissions released to the air in reference to the Paris Agreement commitment for Indonesia. And this CO2 recovered or captured can be utilized for enhanced gas recovery to increase the gas production target in reference to the national strategic project by 2030. And just like any other project mentioned earlier, challenges and risks are present, but they can be mitigated with proper geological storage and injection technique. And here are the references that I used to conduct this presentation. And thank you for the attention.